Okay, so hello, welcome back to another session. Okay, so today we're going to solve some examples with regards to the modified Proctor test. But as you can see, or if you have browsed the PDF file already, there were actually some examples. Okay, prior to the modified Proctor test. But I won't be discussing this anymore because those are actually graphical methods. Okay, for example, ito. Okay, ito na yung sa may unang part. This one. Okay. So, I won't be discussing this na. Inintroduce ko lang yung concept behind yung laboratory test. Okay? Kasi this is actually graphical in nature. So, ang magkakaroon tayo ng problema if kung graphical yung method natin kasi magkakaiba tayo ng values later on and I don't want that to happen. If possible, dapat consistent yung values namin. Dapat pare-pareho siya. So, in the case of the graphical method, kasi, kung siya parang isipin mo, saan ba dito? For example, this one, sabi dito, the maximum dry unit weight daw is 109 pounds as in this graph. Okay. So, ito daw kasi yung 109 pounds. Pero in my case, I don't see that as 109. It could be 109.5, 8.9, mga ganyan. So, magkakaiba tayo ng values later on. So, ayun lang, introduce lang natin yung concept. Okay, feel free to read that na lang during your time. Pero it won't be part of, the graphical method will not be part of your quizzes or activities later on. Okay? So, punta tayo sa modified Proctor test. Okay, so this is our example 1. Okay, for a granular soil, the following are given. GS is 2.6, the liquid limit on fraction passing number 40 sieve is 20, and the percent retained on number 4 sieve is actually 20. So, we have to estimate now the maximum dry density of compaction and the optimum moisture content based on the modified Proctor test. So, yung modified Proctor test natin, we discussed before that there are actually two formulas there, the Omar and the Sridharan. Ngayon, sabi natin, based on the given, dapat alam natin kung anong formula yung gagamitin. Okay, so magbe-base tayo sa given. So, in this case, it is the liquid limit and the percent retained which was given, or which were given. So, in this case, yung gagamitin natin is yung first formula. And I already have the formula in here. So, gagawin lang natin is to substitute the values na lang. Okay? So, we have GS is 2.6. We have the liquid limit 20. Okay? That's for the liquid limit lang of the fraction passing number 40 sieve. And then we have the percent retained which is 20. Okay? 20 for the number 4 sieve. So, direct substitution po tayo. Okay. So, sulat ko dito, raw dry maximum is now equal to 480,457,4 multiplied by 2.6 minus 195.55 times, what is the liquid limit? That's 20 squared plus 156,971 multiplied by 20 raised to 0.5 minus 9527830. Ayan. Sobrang haba nung mga kanyan, ng mga constants niya. So, yung raw Dmax, good thing talaga guys is online to. Kasi pwede nyo lang i-open yung formula nyo. So, we have our raw dry maximum which is 184. I am sorry. It should be 1894 kilogram per m cube. Okay. So, as easy as that, guys. Direct substitute lang tayo. Okay? Next, okay, we need to compute as well the optimum moisture content. Okay? So, ito naman yung formula natin for optimum moisture content. Okay? So, direct substitute ulit tayo. We have ln of the optimum moisture content which is equal to 1.195 times 10 to the negative 4 multiplied by liquid limit which is 20 squared minus 1.964 multiplied by 2.6, okay, minus 6.617 times 10 to the negative 5 multiplied by 20 plus 7651. Okay? So, yung ating ln of the moisture content, okay, sige, diretso na lang natin, no? Diretso na lang pala natin. So, diretso na lang natin, guys. After natin makuha yung term na yan, we now have W optimum moisture content. We just need to take na lang later on yung ganon. No. Sige. Pakita ko na lang. Ayan. ln of, ayan, pakita ko na lang, is equal to 2.591. Okay, so taking the anti-logarithm, we now W opt equals 13.35%. Okay, so these are now the answers. Okay, so ganun lang naman yung modified proctor natin. And in your board exam, ganito din guys yung ginagawa sa board exam. Okay. So, kung may graphical method man doon, binibigay na dati yung graph, guys. Ayan, binibigay na dati yung graph. Okay. So, that's your modified proctor test. Okay? So, yun lang yung modified proctor test natin. As for the standard proctor, yun lang. Medyo may pagka-graphical din kasi yun. Graphical in nature. So, hindi ko alam kung paano natin i-aatakihin yung mga ganung klaseng problem kasi ayun nga, magkakaiba tayo ng values later on pag nag-graphical method tayo. Okay? Unless nagtatanungan talaga tayo, guys. No? Nagtatanungan tayo kung anong value na, especially in the quiz and activity. Di ba? So, ayun. So, proceed tayo sa next. Okay? This one is medyo complicated. Okay? So, in this scenario, guys, kahit mag-focus na lang tayo dito kasi there are actually two givens or dalawang given dito. Okay? The first one is we need to estimate the dry unit weight of compaction in the field. And then the second one is actually the relative compaction in the field. Well, in the case of the second problem, relative compaction in the field, meron na namang yung graphical representation, guys, yung sa laboratory. Kasi kailangan natin ng laboratory value ng gamma. Okay, so meron na siyang gano'n. Ibibigay ko na lang yung gano'n niya, yung gamma niya in the laboratory. Kasi baka para uniform yung calculation natin. Okay? Yung uniform yung calculation natin. Okay. So meron tayo dito. Okay. Meron tayong compaction test result for clay silts given in the table. Now, focus muna tayo dun sa una. Ito, the following are the tests of the field unit weight determination performed on the soil by means of sand cone method. So, meron tayong calibrated dry density of Ottawa sand. Meron tayong calibrated mass of Ottawa sand to fill the cone. We have the mass of the jar, the cone, and the sand. That is before use. Okay, so that's the apparatus. Okay, so mayroon tayong 4.78 kilograms. And then, meron tayong mass of the jar, cone, and the sand after natin siyang gamitin. So, we have 4.78. Okay, and then we have the mass of the soil from the hole. And then, we have the moisture content of the soil. Okay, so, pe-perform natin yung ating, ganyan. Pa-perform natin yung, ang tawag doon, sand cone method in determining the field unit weight of the soil. Okay? Wait lang, nababahinga ako, no? Excuse me. Ayan, medyo masama yung pakiramdam ko, guys. So, pagpasensyahan nyo na, okay? Okay. So, punta tayo dito. So, if you can still remember yung mga W1, W2, W3, mga ganun, guys, gawin ko na lang is, hindi ko na i-follow yung mga annotation doon na W1, W2, ganyan. Gagawa na lang ako ng sarili kong annotation. So, please do not be confused, okay? So, try natin tong, determine natin yung dry unit weight of compaction in the field using yung sand cone method. And that is what is being asked in the first problem. Okay. So, sulat ko yung dito. So, ano yung calibrated density ng Ottawa sand? Select ko muna yung mga given para hindi tayo ma-confused. Okay, eto. So, raw ng dry ng Ottawa sand is equal to 1570 kilograms per m cube. And then we have yung calibrated mass of Ottawa sand to fill the cone. So this is the weight C. Okay? So this is the weight C. Sabihin na lang natin, weight of the sand to fill the cone. That's 0.545 kilograms. Okay? And then we have yung initial mass ng apparatus. Okay, sabihin ko na lang WI. Okay? The initial mass of the apparatus, the jar, the cone, and the sand. Okay? So, hindi pa siya nagagamit. Okay? So, we have 7.59 kilograms. Okay? And then, we have yung mass of the jar, cone, and the sand after natin siyang gamitin. So, sabihin ko na lang W final. Ayan, WF. Okay? So, we have 4.78 kilograms. Ayan. And then yung weight of soil natin, okay, that is the moist soil, okay? So that's 3.007 kilograms. And then yung moisture content ng soil natin, baka ganun kayo, ma-confuse kayo. So artihan ko ng konti yung W. Okay, so 10.2%. Okay? 10.2%. Okay. So, first step na gagawin natin is actually we have to determine the weight of the soil to fill the hole. Okay? So, hindi natin alam kasi kung ano yung weight of soil to weight ng Ottawa sand. Okay? It's the weight of the Ottawa sand to fill the hole that is our main target muna, okay, in the calculation. So, how are we going to determine that? Okay, first, okay, if we want to get the weight of the Ottawa sand that filled the hole, of course, we need first to get yung difference between the final the initial weight of the apparatus minus the final weight of the apparatus, kasi that will give us the weight of the weight of the Ottawa sand that was taken off from the apparatus. Okay? So, first is kunin natin yung weight ng sand to fill the cone and the hole. Okay? So, the difference between the initial weight of the apparatus and the final weight is actually the weight of the mass, or the weight of the Ottawa sand that has filled the hole and the cone. Okay? Kasi kung ito yung apparatus natin, okay, ayan siya, ganyan. Tapos ito yung butas. Ayan. Okay. So, bubuksan natin yung valve, malamang yung Ottawa sand bababa dyan, and then it will fill all of this. Okay? So, ang kukunin natin is, kukunin muna natin yung weight ng sand to fill this portion. Okay? So, that includes the cone and the hole. Okay? So, itong portion na to yung kukunin muna natin. Okay? So, yun muna yung kukunin natin, guys. And how do we get this portion? Kunin lang natin yung W initial minus W final. Okay? Ayun. So, sabihin na lang natin yung annotation ko is WHC. Okay, HC, which stands for weight of the Ottawa sand to fill the hole and the cone, which is equal to W initial minus W final. And with that is equal to 7.59 minus 4.78. Okay, so this is equal to 2.81 kilograms. Okay? So, that is now your WHC. Now, meron na tayo yung weight ng weight ng Ottawa sand to fill the hole and the cone. The next thing that we're going to do is we need to subtract the weight of the sand to fill the cone naman from this WHC. So, we need to get the difference between this, and that will now give us the weight of the Ottawa sand to fill the hole. Okay? So, sabihin na lang natin, ang magiging annotation ko is weight WH, which is equal to WHC minus yung ating WC. Okay? So, yung WH, that's the weight of the sand to fill the hole, which is equal to the weight of the sand to fill the hole and the cone minus the weight of the sand to fill the cone itself. Okay? So, this is now equal to 2.81 minus, what is the weight of the sand to fill the cone? That's 0.545. Okay? And this is now equal to 2.265 kilograms. Okay. So, ayan na guys, yung ating weight of the sand to fill the hole. The next thing that we're going to determine now is the volume of the hole based from the given weight of the sand to fill the hole. Okay? So, what will now be the volume of the hole? Okay? Pwede natin guys gamitin yung density nung dry density ng Ottawa sand kasi binigay naman siya. Calibrated to ha. So, your raw dry ng sand is equal to mass over volume. Okay? So, tandaan nyo guys, yung mga weight na ginamit natin dito, it is in terms of kilograms. Though weight yung tawag natin, it is in terms of kilograms. It's not in terms of force. Okay? So, pwede na lang natin gawin na, or pwede ko na lang i-change to since para maging consistent. Lagay ko na lang weight na lang dito. Okay? WH. Okay? So, ano yung ating density? That is now equal to 1570. That's the density of the sand, kilogram per m cube, which is equal now to 2.265 kilograms all over the volume. Okay? And what is now your volume? Okay? Your volume now is equal to 0.0014426 cubic meters. Ayan. So, that is now the volume. Okay? Ngayon, after natin makuha yung volume ng soil that was actually taken off, or the volume of the hole that was actually dug, okay? Kunin naman natin ngayon yung dry, okay? Yung dry na weight ng soil natin, okay? So, tapos na tayo dun sa testing, okay? It's now the part of the soil that we're going to focus on, okay? Di ba, binigay kanina sa atin yung moist density, okay? Or should I say, the weight of the soil, which is 3.007, okay? So, the weight of the soil that was dug out is 3.007. Pero take note, that's the moist density. So, ang tinatanong doon sa question natin is the dry unit weight of compaction in the field. Okay? So, paano natin to kukunin? Okay? Or paano natin to kukunin? Well, we just need to convert the moist density, okay? The moist, we have to calculate the moist density muna, okay? And then later on, gamitan na lang natin siya ng another formula to get the dry density, okay? Okay. So, identify natin yung moist density ng compacted soil. Okay? So, kunin natin yung moist density ng compacted soil. Okay? So, isulat ko na lang siya dito sa side. Ayan. So, raw moist ng soil is now equal to mass ng soil, or sabihin na lang natin weight over volume. Okay? Yung weight na sinasabi ko dito, once again, this is not ganon. Although it's technically wrong ang term, pero para ganon tayo, para anong tawag doon? Para consistent tayo with the reference din. Weight na lang din yung tawag natin sa kahit mass na siya. Kahit mass yung talagang given. So, what is the moist density of the soil? That is 3.007 kilograms all over. Ano yung volume ng na-compute natin kanina? 0.0014426 m cube. Okay? And this is now equal to what? 2.084, or should I say 2084. Tama ba? Could you please check your calculator? It's 2084 kilograms per m cube. Okay, so meron na tayong moist, raw moist. This is the density of the soil. Now, let's compute now for the, alam mo, i-move ko na nga lang to. Mukhang kung siya, tatamaan siya. So, let's compute now for the, tawag doon. Let's compute now for the unit weight naman. Okay, we just need to multiply this one and then para makuha natin yung dry unit weight later on, kung gagamitin lang natin siya ng formula, yung gamma dry na formula. Okay, so let's multiply this by 9.81. So, gamma moist now is equal to 284.4 multiplied by 9.81. Okay, so that is now your pero divided by 1,000 to. Okay, kasi it's kilonewton, 9.81 meters per second. Okay. Okay, so gamma moist now is equal to 20.45 kilonewton per m cube. Ayan. Next is, madali na lang natin makuha yung gamma dry, guys. So, how do we get the gamma dry? Gamma dry now is equal to gamma moist all over 1 plus water content. Okay? And this is now equal to 20.45 all over 1 plus 0.102. Kasi 10.2% yung ating gamma, yung ating water content. Okay, so this is now equal to 18.56 kilonewton per m cube. Ayan. So that is now the answer for question number 1. So we have 18.56. Okay. So the next question is, ito yung sinasabi ko sa inyo, okay, part B. Okay, if you check the book of Braha M. Das, which is our reference, graphical method kasi yung laboratory. Okay, so in here, ayan. Okay. I-determine daw natin yung relative compaction. Okay, kasi meron siyang binigay na relative compaction. Kasi di ba yung relative compaction natin based on the problem, yung binigay kasi sa problem, meron siyang laboratory, ito. Okay, so meron siyang laboratory test and then meron yung field test. Itong field test natin, that's for the Ottawa sand, yung Ottawa sand na yan. That is actually your ganon, yung field ninyo na gamma. Okay, gamma dry na field. Pero in order for you to determine yung laboratory, you have to plot this. Okay, ipa-plot natin yung dry unit weight versus yung moisture content. And then, kailangan natin i-determine yung optimum moisture content and the maximum dry unit weight. Okay? So, ito yung plot niya, guys. Ayan. 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 Okay. So, we have, ito yung plot niya. Ayan. Okay. So, sabi dito sa book, yung optimum moisture content is somewhere here. Ayan. Somewhere here daw. Ayan. And, yung gamma dry maximum in the laboratory is somewhere here. So, sabi niya, it's 19 kilonewton per m cube. Okay. So, yung formula kasi natin for relative compaction, that's gamma dry in the field all over gamma dry in the lab. Okay. Pero meron pa naman tayong ibang formula. Only that, yung given kasi natin is actually this. Yung, ito lang, yung mga given natin. Okay. So, yung iba kasi ata, I think, may gamma minimum, ganun. Ay, gamma dry minimum, gamma dry, mga ganyan, kineme. Wala naman binigay na sa problem. So, this is how we're going to do it. Okay. So, in here, sabi dito, the gamma dry maximum ng laboratory is, siguro, kung may problem man tayo na ganyan, bibigay ko na lang yung gamma dry maximum agad para consistent tayo. Okay. So, in here, relative compaction, madali lang, lagay lang natin. This is now equal to, what is our gamma dry in the field earlier? That is 18.56. Divided by yung laboratory na gamma dry. Okay, that's 19. Ayan. So, this will now give you 97 point, okay, or should I say, multiply na natin ito ng 100. Kasi we have, it should be in terms of percent. So, this is now 97.7%. Ayan. So, this is now your relative compaction. Ayan. It's just the ratio of the gamma in the field and the gamma in the lab. So that is your relative compaction as well as your field density. Okay? So, our field unit weight. Okay? That is how you're going to do it. Ayan. So, medyo siguro confusing lang yung part, pero kailangan nyo lang i-label yung inyong mga data ng mabuti, just like what I did. Ayan. Okay. So, yun lang naman, guys. Okay, let's proceed to the special compaction. Ito, sobrang dali lang nito, guys. Hindi na tayo kailangan mag-isip-isip pa ng gano'n, ng sobrang hirap. Okay, so ito naman is special compaction techniques, yung may suitability number. I don't know if you can still remember. Okay, isulat ko na yung formula for suitability number. Sabi kasi dito, determine the suitability number and what would be its rating. And binigay na sa atin yung mga components. Okay, ito na yung mga components niya. Okay, so wala na tayong problema. So yung problema na lang natin is hindi natin memorize yung formula. Okay, pero in your case, for sure that you know that because it's actually open notes. Okay? Yeah. So this is square root of 3 over d50 squared. Okay. Oh my God, mukha siyang 80. Ayan. d50 squared plus 1 over d20 squared plus 1 over d10 squared. Okay. Yan. So, rekta na tayo. What is the suitability number? That's just equal to 1.7. The square root of... Ayan. Runny nose ako, guys. Pagpasensyahan nyo na, this is really inappropriate. Okay. It's really inappropriate, pero wala na akong mag-agawa kasi I'm not feeling well. Ayun lang. Kinakaya pa naman natin. Okay. Ayan. So, runny nose tayo, guys. So, this is 1.42 squared, ayun guys, d50 is 1.42, d20, 0.52, and 0.36 ang d10. Okay, plus 1 over 0.52 squared plus 1 over 0.36 squared. Okay, so your answer will be 6.1. Okay, and if you still remember, I think 0 to 10, kapag yung rating mga ganyan, this is actually excellent. Okay, excellent siya. Okay. So, meron tayong table nito, guys, doon sa LMS. You just have to check it. Pero I think this is excellent kasi 0 to... Yun lang yung na-memorize ko, yung 0 to 10 lang. Okay. So, what is the rating? Okay. The rating now is excellent. Okay. Okay. Just like you guys, you are very excellent. Ayan. Okay. So, that is our SN and that is our suitability number. I rather yung rating natin. Ano pinagsasabi mo, Sir Ju? Ayan. Ayan. Okay, so that is those are our examples for soil compaction. Okay, so if you have questions later on, feel free to PM me. Kung gusto niyo ng one-on-one session, sige, pagbigyan ko kayo. Okay, and ayun lang naman, guys. You just have to just study this one. I've already sent the PDF file as well as the anong tawag doon? I already sent the PDF file and the video. Okay, the video. So, much better, guys, kung habang nanonood kayo ng video ko, okay, yung mga walang kwenta kong video, is tinitignan nyo yung mga PDF file ninyo, or you're trying, or you have wrote down, or you have transferred the contents of the PDF file to your own notes. Kasi mas maintindihan nyo siya kapag kayo yung gumawa, or kayo yung mismo nagsulat. So, yun lang naman, and thank you guys for listening. Okay? So, I apologize din kung medyo late na. Pero, ayun, bawi na lang ako sa inyo. Thank you guys. Bye-bye.